Good morning. Today we are going to see about carbon group of remedies, hydrocarbons. Hydrocarbons are invisible backbone of the modern daily life. Far beyond just powering cars, they provide the chemical building blocks for almost every room you walk into, the clothes you wear and the food you eat. In your kitchen and food supply, cooking gases, natural gas, methane and bottled LPG provide immediate flame heat for cooking, food preservation. The plastic cling wraps, Ziploc bags, and the Tupperware keeping food fresh are made from polyethylene and polypropylene polymers derived from oil. Agriculture. Synthetic fertilizers like urea and ammonia are manufactured using hydrogen cracked directly from natural gas feeding global crops. Refrigeration. Modern eco-friendly fridges and air conditioners use hydrocarbon gases like isobutane as a refrigerant instead of ozone-depleting CFCs. In your wardrobe and personal care, synthetic clothing, polyester, nylon, spandex and acrylic fabrics are entirely made from petroleum-derived petrochemicals. Skincare and cosmetics, Vaseline, petroleum jelly, mineral oil, paraffin waxes and the solvent used in perfumes and lipsticks rely on refined hydrocarbon fractions. Hygiene products, the plastic housing of your toothbrush, shampoo bottles and synthetic fibers in diapers or sanitary pads are oil dependent. Around the house, electronics, the external casing of your smartphone, laptops, and the insulation wrapping electrical wires are made of specialized plastic like ABS and PVC. Furniture and flooring. Polyurethane forms inside your mattress and couch pillows. Synthetic carpets and vinyl flooring PVCs are all synthesized from hydrocarbons. Cleaning agents. Many household laundry detergents and surface cleaners use synthetic surfactants derived from petrochemicals to lift grease. Transportation and infrastructure. Fuels. Gasoline, diesel and jet fuel dictate the global movement of people, Amazon packages and grocery shipments every minute. Roads. Asphalt is the heavy sticky hydrocarbon residue left at the bottom of oil refining towers used to pave virtually all modern roads. Vehicle. Beyond fuel, a modern car contains hundreds of pounds of plastic, synthetic rubber tires and specialized hydrocarbon lubricants, motor oil to prevent engine failure. Medicine and healthcare. Medical equipment, sterile syringes, IV bags, tubings, heart valves and protective nitrile glove requiring high purity medical plastic. Pharmaceuticals, the chemical synthesis of everyday over-the-counter drugs such as aspirin, ibuprofen, begins with benzene and other aromatic hydrocarbon precursors. Let's see some advanced uses of hydrocarbons. Quantum computing and molecular spintronics. Rather than transporting electricity through copper wires, advanced computing utilizes the spin of an electron to process data. Hydrocarbons are the foundational precursors used to grow hyper-precise carbon nanomaterial for this purpose. Chiral carbon nanotubes. Hydrocarbon gases are cracked to grow carbon nanotubes with precise twist configuration, chirality. Depending on the geometry, they can act as metallic conductors or high mobility semiconductors, forming the backbone of sub 2 nanometer transistors that surpass silicon. Rhombohedral graphene superconductivity. Synthesized from hydrocarbon precursors atomically thin sheets of rhombohedral graphene exhibit unique quantum properties. Electrons localize strictly on the outer surface, generating emergent superconductivity where electrical current flows with zero resistance. Nitrogen vacancy diamond quantum sensors. Methane is cracked in microwave plasma reactor to grow synthetic quantum grade diamonds. By engineering a single nitrogen defect next to a missing carbon atom, scientists create quantum sensors capable of measuring single cell magnetic fields or detecting structural stress in microscopic materials. Aerospace and deep space exploration. The extreme thermal stability and strength to weight ratio of hydrocarbon derived material make deep space travel viable. Carbon-carbon composites. Methane and specialized aromatic hydrocarbons are pyrolyzed to embedded pure carbon material into woven carbon fibers. These composites can withstand temperature exceeding 3000 degrees Celsius, making them irreplaceable for rocket nozzles, hypersonic leading edges, and spacecraft re-entry heat shield. Carbon aerogels, formed by extracting the liquid from hydrocarbon-based gels and replacing it with gas. These are lightest solid materials in existence. NASA utilizes them as high-efficiency thermal insulation to protect Mars rovers from freezing and as cosmic dust collectors to capture hyper-velocity space particles. Electrospray propulsion thrusters. Advanced space satellites like CubeSats utilize custom-designed heavy liquid hydrocarbon molecules as propellant. Under intense electrostatic fields, individual ions are ripped from the liquid and shot out of microscopic nozzles, providing hyper-precise maneuvering thrust in orbital vacuums. Structural supermaterials and space elevators. The ultimate limits of mechanical engineering rely on turning simple hydrocarbon chains into macro-scale structures with unprecedented tensile strength. Graphene nanoribbons. Methane and ethylene are unzipped or chemically stitched together to form ultra-strong pure carbon ribbons. These possess a theoretical tensile strength 10 to 115 times greater than steel at a fraction of the weight. Tether technology. Scientists use these carbon ribbons as only viable candidate material strong enough to theoretically construct a space elevator cable as continuous tether reaching from Earth's surface directly into geostationary orbit. Precision biomedicine and molecular delivery. By manipulating the aromatic rings found in hydrocarbon, biochemists construct artificial delivery vehicles that at the nanometer scale. Superatomic fullerene nanosheet. Hydrocarbon are synthesized into close-gauge carbon structure called fluorines C60. These structures can be engineered to act as molecular cages. They trap toxic chemotherapy drug inside, shield them from the body's immune system, and release them exclusively when they attach to a cancerous tumor. Graphene biosensors. Microscopic hydrocarbon-grown graphene sheets are integrated into the single-use paper chips. Because graphene is highly sensitive to any change in electrical conductivity, it can instantly detect the presence of specific viral DNA or toxic gases at the parts per billion level. Let's try to understand hydrocarbons in Rajan Shankaran's concept. Rajan Shankaran's system relies on the sensation method, which identifies the core non-human experience of the patient. Remedies are categorized by the kingdom, mineral, plant and animal, and their miasm, the pace, depth and desperate perception of the problem. Because these four substances are fundamental carbon compounds, they all share the core mineral kingdom theme, structure, identity and existential security. Within Shankaran's framework, they express these themes through specific miasmatic lenses: petroleum or crude oil, miasm, typhoid soric, fluctuating between sudden crisis and chronic struggle, core sensation, a feeling of being exposed, raw or completely uninsulated. The individual feels as though their skin or boundaries are physically and emotionally cracked open. Shankaran's interpretation: petroleum represents an elemental, unrefined state of mineral kingdom. The person feels a desperate acute need to find shelter or protection from a harsh environment, heavily reflected in the physical symptoms of deep, bleeding skin fissures that worsen drastically during winter. Creosotum. Beechwood creosote. Miasm, syphilitic, destruction, decay and irremediable ruin. Core sensation, a sense of being severely wronged, abused or fundamentally soiled, leading to rapid corrosive destruction. Shankaran's interpretation: creosotum is treated with the gravity of a highly destructive malignant process. The sensation is one of internal rotting and burning. This manifests in the rapid premature decay of teeth, ulceration and acrid excoriation, bodily discharges that burns the surrounding tissue. Carbonium sulfatum. Miasm, syphilitic malarial, sudden periodic attacks of destruction. Core sensation is a deep burning breakdown of the structural nervous tissue paired with intense vulnerability. Shankaran's interpretation, here the core carbon sensation, that is loss of identity, self-worth, is combined with the sulfur sensation, feeling unappreciated, criticized or scorned. The patient feels a chaotic progressive decay of their fundamental nervous and physical framework, often resulting in profound peripheral neuropathy, tingling, and a total collapse of physical vitality. Carbonium oxygenacetum. There is carbon monoxide, miasm, acute apoplectic, a sudden life-threatening emergency. Core sensation is utter helplessness, paralysis, and sudden violent deprivation of life force. Shankaran's interpretation. This remedy embodies a state of sudden asphyxiation. The sensation is that of catastrophic, unexpected event where the ability to breathe, think, or defend oneself is instantly cut off. The psychological expression is a state of deep zombie-like apathy, mirroring actual carbon monoxide poisoning. John Scalton's concept. John Scalton's element theory maps the periodic table to human developmental psychology. Carbon belongs to the carbon series rho 2, which represents the developmental stage of young child discovering their ego, personal identity, self-worth, and separate physical existence. When carbon is bound to other elements, Scalton breaks down the remedy by combining themes of carbon series with the stages. There is a column or accompanying columns and accompanying elements. Carbon series theme is individual ego and self-worth. Cryocetum is a phenolic mixture, stage rigid, acidic, decaying identity. Petroleum, complex hydrocarbon, stage saturated, buried, unrefined ego. Carbonium compounds, sulfides and oxides, stage disintegration, suffocation, or relationship loss. Petroleum, crude oil, Scalton's integration. Petroleum is a complex, dense mixture of hydrocarbon chains. In Scalton's view, it represents state where the individual's identity is heavily weighed down, buried, or trapped under immense pressure. Psychological profile. The person struggles with an unrefined primordial ego. They feel their true value and identity are hidden or obscured by a chaotic, dirty, or swampy environment, making it incredibly difficult to establish a clean, independent sense of self. Cryocetum, beechwood, and creosote. Scalton's integration. As a distilled tar rich in phenols, cryocetum contains carbon, hydrogen, and oxygen. It represents organic matters that has undergone intense heating and chemical breakdowns. Psychological profile. Scalton views cryocetum as an identity that feels prematurely aged, ruined, or decaying. The individual's self-worth has been completely corroded by past trauma or harsh condition. This often produces a bitter, defensive, or highly reactive personality structure. Carbonium sulfuratum. Scalton's integration. This is a direct combination of carbon series, ego, self-worth, and silicum series, sulfur, relationship, love, and harmony. Psychological profile. The central conflict revolves around the individual's value within a relationship. The person feels that their partner or social circle completely devalues, burns, or consumes their identity. They experience a profound loss of self-worth because they feel unloved or rejected by those closest to them. Carbonium oxygenatum. Carbon monoxide. Scalton integration, a combination of carbon, self-identity, and oxygen, which Scalton places in stage 16, decay, corruption, bankruptcy, taking or giving. Psychological profile. Scalton describes this as a state of existential suffocation. The ego feels entirely starved of its vital force, leading to severe apathy. The individual feels like a living ghost or an empty shell, as if their property, identity, or very breath has been stolen away, leaving them completely powerless. Let's integrate this with dimensions, quantum theory, and evolution. If we move beyond psychological metaphors, these same four carbon components trace the actual physical journey of cosmic, geochemical, and biological evolution through the laws of quantum mechanics and dimensional geometry. In one-dimensional interaction and cosmic evolution, carbonium oxygenatum dimensionally governed by one dimension linear axis connecting two atoms. Quantum configuration: the carbon atom undergoes sp hybridization. It forms a highly stable triple bond with oxygen consisting of one bond and two pi bond, one of which is dative coordinate covalent bond where oxygen shares its long pair into carbon's empty orbital. Evolutionary role: carbon is originally forged in the core of dying stars via the quantum tunneling of three helium nuclei. When it ejects into interstellar space and bonds into carbon monoxide, it becomes the second most abundant molecule in the universe. Carbon monoxide acts as a crucial galactic coolant by radiating rotational quantum energy away into the vacuum of space. It drops the temperature of interstellar molecular cloud. This allows gravity to overcome kinetic pressure, triggering the collapse needed to birth a new star system and rocky planets. Two-dimensional volatility and geochemical evolution. Carbonium sulfuratum. Dimensionally, a two-dimensional linear planar geometry operating as a volatile, highly refractive liquid phase. Quantum configuration: the carbon atom remains sp hybridized, forming two linear double bonds with two sulfur atoms. However, because sulfur is a period 3 element, its 3p valent orbitals are significantly larger and more diffuse than oxygen 2p orbitals. This mismatch creates weaker, highly polarizable pi orbital overlaps. Evolutionary role: during the early geochemical formatting of planet Earth, volatile sulfides like CS2 were constantly outgassed by volcanic activity. Because of its weak quantum orbital overlaps, CS2 become an exceptional non-polar solvent. It dissolves heavy inorganic material and establishes the dense sulfur-rich chemical gradients necessary to fuel the primitive redox reaction that preceded the spark of metabolic life. 3D macromolecular and biological evolution. Petroleum. Dimensionality: fully realized three-dimensional structural geometry utilizing tetrahedral branching to build volume. Quantum configuration: carbon atoms undergoes sp3 hybridization. It promotes an electron from 2s orbitals into a 2p orbital, creating four equivalent hybrid orbitals directed towards the vertical of three-dimensional tetrahedron with the bond angles of 109.5 degree. This configuration unlocks carbon's unique capacity for catenation, the ability to form long, extraordinary, stable, repeating covalent CC bonds, alkalines and cycloalkalines. Evolutionary role: petroleum is a physical preservative of ancient life created from millions of years of ancient photosynthetic phytoplankton compressed under geological layers. These hydrocarbon chains represent a massive thermodynamic triumph. They are stable, high-density storehouses of solar energy, originally captured via the quantum excitation of electrons in the chlorophyll, converted into 3D molecular structures and buried to form the foundational energy bedrock of modern industrial evolution. 4D spatio-temporal decay and ecological evolution. Cryostatum. Dimensionality: 4D spatio-temporal evolution representing the irreversible arrow of time, biological entropy and the recycling of matter. Quantum configuration: cryostatum is a complex mixture of aromatic phenols such as guaiacol and cresol. It relies heavily on sp2 hybridization, where carbon forms planar hexagonal rings. The unhybridized 2p orbitals overlap vertically, creating a delocalized cloud of pi electron that moves freely across the ring, granting the molecule immense resonance stabilization. Evolutionary role: cryostatum is obtained from the thermal pyrolysis of wood lignin, which is one of the most complex biopolymers evolved by land plants to defy gravity. Because these aromatic rings possess high quantum resonance stability, they are incredibly difficult to standard enzymes to tear apart. Cryostatum represents the exact point where evolution utilizes quantum stability to slow down ecological decay, acting as a natural antimicrobial preservative that ensures carbon cycle back to the biosphere at a controlled, sustainable pace. That's all for today. Let's see tomorrow. Thank you.